In this module, we'll focus on detecting and resolving model errors, which is something that each of you, as you become more proficient using simulation, should get more and more used to doing. And that probably sounds a little bit strange, that the more proficient you become, the more you need to get used to debugging and resolving model errors. But that's in fact true, that no matter how much you model and how good you are at modeling, you spend a lot of your development time and a lot of your simulation time actually trying to find and correct model errors. And as a note here, it can be, as I say, very time consuming, and it's usually quite frustrating, and it's generally more frustrating for those who are new to simulation because they don't think they should be doing that. In general, there are three classes of errors that we encounter during the development and implementation process, and we're going to talk about all three of these. The first type is called syntax errors, where you're using incorrect usage of the language, or you misspell something or something like that. Runtime errors, where the actual model runs and at some point it encounters an error situation during the model run. And finally, logic errors. In a logic error, your model is correct and runs totally error-free, but it just doesn't give you the results that you expect, or it doesn't give you the results that are correct. So you have made a logic error somewhere in your model. So syntax errors are errors where you mistype something in general, or you've done something that's syntactically incorrect for the package you're using. And most commercial simulation packages, including SIMIO, they automatically look for these types of errors, and they're generally fairly easy to detect and fix. So let's say, for example, that we have this model, a model fragment, and in the server I was going to enter the processing time, and what I wanted was exponential. But I mistyped it, and instead of exponential, I have exponentia. And so you can see what SIMIO does here is it colors the property name using this peach or salamander color, and then brings up an error window and won't let us run the model. So SIMIO has detected that this is an error and is giving me as much information as possible in order to fix that. And so in this case, if once we correct the spelling, random, then our error, our syntax error goes away. Another type of error that I would refer to as a syntax error is when, for example, we use an existing keyword. So for example, suppose I was going to set a reference property and I want to use the reference property initial capacity. Then SIMIO is going to tell me with this with the stop sign here that there's already an existing expression property, and so you can't do that. And so whether or not that's technically a syntax error, it falls into this class of errors that SIMIO will help me try to identify. Similarly, if I try to assign a value to, say, a non-existent state, so I go to my state assignment and I want to assign the, let's say, model entity arrive time. And the SIMIO is telling me now that there is no such property. And so in this case, or there's no such state. So in this case, this might be an error where I had just forgotten to create that entity state, and I would now need to go back and do that. So regardless of how you actually come to the syntax error, in general, as I mentioned, they're generally easy to find and fixed. And I have a little caveat here that they're easy to find and fix once you understand the rules of SIMIO, or whatever language you happen to be using. You need to understand the syntactical rules of where it's possible to reuse names and so on in order to fix these. But once you understand that, they're generally very easy to fix. The second class of errors that we'll look at are called runtime errors. And a runtime error is an error that occurs while the model is running. So in this case, we'll bring back up our model, and we can see that I have forgotten to provide a path for entities that depart source 2. And so in this case, source 2 has a time offset of 2.5 minutes, and so the first entity doesn't arrive until time 2.5. So when I now run my model, everything looks correct. The model is running, so the model is syntactically correct, but when I reach 2.5 minutes, as you see, we have this error that says entity or default entity.29 failed to initiate transfer from node. So I can show some additional details from the window here. It says the output of source 2, and now SIMIO is saying, should I continue running or should I pause the simulation? So in this case, it errored, and the error would hopefully provide us enough information to figure out what we've done here. As another example, let's say that we have this source, the path appropriately, but we are adding feedback. So we are going to add maybe a rework loop here, and when we do that, we forgot to put the path back in from server 1 to the sink. And so now when I run my model, again, it's syntactically correct, and we're going to run, because we will run past the 2.5 minute mark because we fixed this problem. But as you can see, entities have nowhere to go because they can't depart the system. They continue to loop back. And so if we run long enough, we will get a warning that looks similar to this, which says the maximum number in system limit for objects of this type has been exceeded. And so we can pause the simulation, and let's actually stop it, and let me bring up the default entity. And when we look at the population properties, there's where this maximum number in system limit comes from. So if I change this value, say to 4,000, oops, not 400, let's make it 4,000, and I rerun my model, again we'll just run in fast forward mode, we will eventually come to the same problem, that we've exceeded this number because the entities basically have nowhere to go. So when we get this error that you've exceeded the maximum number, it might or might not actually be an error. It might be that we have more than 4,000 entities in our system, and that's perfectly valid. Or it may be the situation that we see here where it is an error. And so in this case, SIMIO has no way of knowing whether it's an error situation or whether it's something that you expect. So you have to make that decision once you're provided information. So again, a runtime error is one where the model is syntactically correct, but that eventually it stops in an error condition. And so we saw the failure to add the path there, and then we saw this second example where we have this loop back. The third general class of errors that we run into are logic errors. And a logic error is where the model is correct in the sense that it's syntactically correct and it runs without errors, but it's just not quite right. So there's a logic problem in your model where it's not reflective of the system that you're trying to model. And unfortunately, there's no way that SIMIO or any other language has any way to help you or any way to identify these types of situations because they're pure logic errors. And so with logic errors, the detection and resolution techniques are really just a series of tools that we use to try to identify where the errors occur. And so I'm going to talk about a few of these debugging tools and techniques. And clearly the first one is to just carefully watch the animation. One of the strengths of having animation is that we can actually see what the entities do, and so in this method we're actually using that to try to make sure that the model is doing what we think it does. The second general method says let's enhance the simulation with debugging information and messages. So I have an example here of a model that I was working on with a student. And I won't get into detail about what the model does, but suffice to say that as part of the model, the entities, let me go over here to my definitions, have two entity states. One is called my role, which is assigned, and the other is called num tries, which identifies how many tries were made in order to identify a role. So in our model, we have a process that performs this assign step. So there's some decisions that are made, have some further decisions and looping back and so on. But essentially in the assign, we think that what we're doing is we're incrementing the number of times that an assignment was made, and then the entity ends up with the state. And so we added to our default entity the floor label, the attached floor label, and in this case our attached floor label shows the two entity states of question. So my role and num tries are shown as the floor label, and so when we run the model, when entities arrive and go through the assignment process, we can see the value. So this is the role and this is the number of times it took to achieve that role. And so by adding this status information as the simulation runs, we can actually get a better view of what's going on. Another very common piece of status information that we use status labels. So I can select my sink in this case, and I can add a status label, and my status label is attached to the sink. And so, for example, I could do something like, oops, I got to stop the model first, and let's add this status label of input. Back and try that one more time. I'm going to add input buffer number entered. And so what we have in the status label now is the number of entities that enter the input buffer of sink. So in this case, we only have one sink, but you can certainly imagine cases where we have alternative sinks, and we would want to be able to monitor the number of entities that entered in each sink. And so by using status labels, and in this case floor labels, we're hopefully providing some additional information that will help us monitor the system and figure out what's going on. This third class of debugging tools, what I'll refer to as step mode, and then adding mouse overs. And so let's go back to our model, and let me see here, which one do I want? I want this one. And in this case, in this time, instead of running, I'm going to go to the run menu, and I'm simply going to click on the step. And what the step does is it starts the simulation, and it runs one step of one entity. So when I'm in the facility view, one step is equivalent to the movement of a single entity. And so I can step again, and now we see the entity has moved, and step again, and now the next entity, and so on. The idea of mouse overs, basically when I hover the mouse, it gives me some information about what the entity is, or it gives me some information about which entity I'm currently looking at. So another method that's related to that involves using what are called watches. A watch, let me go back to my model, I can at any point right click on, for example, the entity realization and click on watch, and it will set a watch on that entity and then open the watch window, and we can then interrogate and get basically all of the information about that particular entity. So in this case, I'm looking at the entity 11, and I can go down and look at the two states that I'm interested in, my role and num tries. They haven't been assigned yet, so I can click on step, and now you can see that those two turn red and the actual assignment has been made. So by watching and using step mode, I can get information about the entity realizations. I can also look at servers or other entity instances, so I can click watch, and so I can look at server 1, for example, and as with the entity, I can get basically complete information about server 1. So I can see there are no entities in the input buffer, there are no entities processing, and so on. So watches let us provide, or let us interrogate the model while it's running and collect or view the information about each entity, object instance or object run space. The next general method that we'll use are called breaks or breakpoints. So I can go back to my model, and let's stop the model, and let's right click on server 1 and add a breakpoint. So now we can see the little hand symbol signifying that there is a breakpoint, and I can run my model, and the model will run until the first entity interacts with the server. So we can see that happen at time point 01, and we can see the little notification here that we were stopped because of the breakpoint. So I stop, and I can step, and I can continue to run, and every time an entity arrives at the server, the simulation will stop. I can also use breakpoints not in the facility view, but also for individual process steps. So let's go back and let's stop the model, and I'm going to set a breakpoint here before I fire an event. So in my model, I have entities that are arriving at a station. I count, and when 5 entities arrive, I pull those out and transfer them, and I fire an event. And what I want to do is I want the model to stop right before I fire the event. So I can go back in run mode, and I can just fast forward, and now we've reached that breakpoint. And so if I then look at my watch, and in particular the processing buffer contents, or I'm sorry, the processing station, I can see the 5 entities that are in server 1 processing station. If I fast forward again, then the breakpoint will cause the model to stop at the exact same point. So these are the next 5 entities that are in the processing station. Fast forward again and again and again, and you can see with the breakpoint it allows us to stop the execution of the model precisely where something of interest happens to us from a debugging perspective. The next method that we'll look at is by using so-called model trace. And model trace is very useful, but generally is pretty scary to new users. So let's have a look at what that does. So I'm going to first clear my breakpoint, and I'm also going to clear the watches that I had before. So I'll stop my model from running, and I will clear the watch there. And I'm going to go to the ribbon, the run ribbon, and turn on model trace. And you can see what happens is it opens the trace window. And now I'll just run the model for a little while. And you can see what's happening is in the trace window, we're seeing the simulation execute on an event level. So let it run for just a second, and I'll just stop or pause the model there, and we can scroll back to the top, and it's got by simulation time, the entity involved, the object involved, the process that was running, and then the token information about what happened during that process. And so you can see basically all of the events that occur. So for example, I go back to my processes and I have this output on source 1 entered add-on process that I make the assignment that I mentioned earlier when entities arrive. I can simply go to my trace window and click on the filter and just filter on that one process, and I can see all of the events associated with that process. So we can see that default entity 10 arrived at time 0 and went through the processing steps. So the begin, the decide, the assign, the search, the begin, the decide, the assign, the search, the decide to, and so on. And so we can see the actual result of all of the steps. So in this case, the assign that I'm interested in was assigning the num tries the value of 1 and assigning the my role the value of 4. Then I can scroll down in my trace and see that the next invocation of this process happened at time point 0065, and it was the next entity, default entity 11. And we can see that the num tries value was set to 1 and the my roles value set to 3. And so I pause the simulation, I can go back, and I can also execute in step mode. So I can continue to execute, and you can see what happens is we continue to monitor the events. Let me clear my filter here, and step again, and step again, and step again, and we can see the execution of the simulation at the event level. Also note that if I go in the process, and instead of clicking on the step, I hit the F6 key, you can see that we are actually executing the model one step at a time at the process level. So one event is happening at a time. So there are two different granularities of step mode. Both can be quite useful from a debugging perspective. So as I mentioned, the trace option or the model trace is generally very intimidating to new users, and they really try to shy away from it, but I can tell you it's extraordinarily useful. And in many times when you have a highly complex model, you have a situation that you just can't seem to figure out what the problem is, really the only way to debug that is to look at the model at the trace level. Also note that the windows are dockable, so I can pull the trace window out, and if I happen to have two monitors or I have a bigger monitor, I can place the window in a more convenient location to watch the model run. And so as you begin to build more and more complex models, you should definitely try to become more and more comfortable with the trace feature, because it can be extraordinarily useful. The next method I'm going to talk about is subclassing objects. And so let's go back to our model and have a look at that. Oops, I want the other model. And so let's say that I'm debugging this model. So let me stop the model. And I just, something that unexpected is happening in the server. I'm just not getting the behavior that I want. And so a lot of times what I really need to know is exactly what's going on inside the server, right? I don't want to know from a high level. I want to know exactly the sequence of events that occur. I can do that if I'm using one of the objects from the library. If I just go over to my server object and then right click, when I do that, I see this option called subclass. So if I click on that, what happens is I create an I create an object definition called my server, which is a subclass of the standard library server object. And the benefit of doing that is when I click on the process, I can see at the process level exactly how the server object works. And so when something unexpected happens and I just can't figure it out, I can subclass the object, go in and study the object at a process level, and hopefully figure out what the anomalous behavior is that I'm seeing. And I can subclass any one of the objects in the standard library to try to figure out exactly what's going on. So subclassing objects we use when we create our own objects when we want to modify the behavior, but subclassing is also very useful from a debugging perspective when what I really need to do is just understand exactly what's going on. The final method that I'm going to talk about is called the notify step. And so the notify step does exactly what the name implies. It allows you to give yourself or give the model or the person executing the model a notification of something happening. So let's go back into our process before where we had a breakpoint on the fire, on the event firing. This time what I'm going to do is I'm going to go over to the all steps and I'm going to scroll down and I'm just going to grab the notify step. And when I place that, we can see that we have a notification type, and there are two types. There's a trace or a warning. I'm going to change it to warning, and then I'm just going to put in the message heading about to fire. And then in the message content, I'm going to just leave a little bit longer message. There are 5 entities here, and the event is going to fire. And now what happens when I run my model, let's run it there, and we can just run in fast forward mode. We can see that when the notify step is hit, it provides us information. So about to fire, there are 5 entities, the event is going to fire. At this point I can continue running, and it tells me again, they're about to fire. I can also pause the simulation and then go back and do whatever debugging step I need to do. Also note that the second option, if I have notification type of trace, then the notification is not going to interrupt the execution of the model. Instead, it's going to be sent to the trace. And in this case, I didn't have the trace on, but the notifies still show up. And so if I now reset my model and I run, now the notification steps will show up in the trace, as with the rest of the events that fire. And so you can see that by using the notify step, we can put user notifications at various points in our model to simplify the process of figuring out exactly what's going on. That's really the key when you're doing debugging and detecting errors, is to really understand what's actually going on in your model and comparing that with what you think is going on and what you actually want to go on. So understanding what's really going on is the ultimate key to doing model debugging.